Hello, Flat Earth researchers, debaters and debunkers. If you believe that the horizon is a curve like this hill and that ships then go down below the curve or come up from the curve like that bike just did, then what should happen the moment you begin to gain height is that horizon should drop like this, because that is a physical thing. Yeah, the hill is physical and it stays in one place, so it appears to drop or get higher when you go down. So anyone can test this for themselves and see that horizons are not a physical thing, because they always remain at your eye level when you look straight ahead, no matter how high or low you go. Yeah, when we go down low and this surface is curving, it goes above eye level. Yeah, and then when I rise up, it goes below eye level. But with a horizon that you see in front of you across vast stretches of land or sea, the horizon remains at eye level, which tells us it's not a physical thing. It is an optical illusion, if you like, of perspective. If it was a physical thing at eye level, then what do you think would happen if you went forwards? You'd run into it and you'd hit it. It's very simple. There is a difference between a physical hump or rise, and of course you can see here as well. You can see that this is a hump and it rises up in front of us because it's a physical curve. You don't see that when you look across water, do you? You know it's flat. So any excuses about, oh, it's just a ring around you and it looks flat. It looks flat because it is. And the horizon is level and flat because that's what perspective does. The surface rises up to eye level and the sky comes down to converge with that. Really simple stuff. That's all there is to it, really. So it's just cognitive dissonance if you want to claim that horizons are some kind of hump of curvature. And it's ridiculous anyway to think that a horizon that is supposedly 3 or 4 miles in front of you because you're at a certain height is something to do with the size of a globe anyway. It's just a illogical statement, because the size of a globe shouldn't change. So nor should the distance to the horizon. And the distance, you know, you can't measure. You can kind of estimate the distance to this that post over there, because we've got all these visual clues around us. We know the average size of a road, or if this was a stretch of water, we know what waves look like. So we've got all these visual clues to give us an idea, but you can't physically measure from this perspective unless you take a tape measure from here to that post and measure the distance, or use some kind of radar or whatever. Yeah, but you cannot tell the distance from this perspective, only when you have a side-on view. Yeah? So there are so many illogical statements and arguments about, they're just explanations, ridiculous explanations for the fact that nothing looks like we're on any kind of ball, but you have to kind of explain away all these different things which don't make logical sense to try and explain that we're on a ball. Horizons are not curvature, and there's no way on this earth that anyone would think or believe that the horizon in front of you has anything to do with us being on a curved surface, unless you've been repeatedly told since you were a kid. Yeah? It's time to get off the ball and get real. Thank you very much.